We are back with another final project for our PCS 7 tutorial. This example is tank station. Tank station example is one of final projects for PCS 7 tutorial. In this project, we have 3 tanks, and we will manage their level and temperature values based on sequence. The sequential part is implemented with SFC in PCS 7, and control section is done by embedded PID blocks in PCS 7. This project can be done in other platforms with similar tools. There is a binary signal to start the whole procedure. The negated version of a start signal can be used in reset mechanism. We recommend to use an FB that is developed in SCL for base control and simulation. After 20 seconds, while the start is active, tank A is getting filled with a variable ratio. When level is more than 55, regulate the level for tank A on 50% and temperature around 50 centigrade. For level and for temperature and level controlling, PA is used to pump the liquid to the exchanger and drain area. This is PA. We use PA for discharge and for circulating in order to maintain the temperature. If the liquid is cooler, we need to use a hotter liquid or hotter media here to warm up the tank content. And after reaching to a steady state in PID, find your best condition for PID steady state. Export to tank C is started. When tank C is reaching to 30%, export valve will close. This is the export valve from tank A to tank C. Tank A to tank C. The next step will be starting FB PB. Fill the tank B. We fill the tank B here. When level in tank B is reaching 100%, XB will transfer it to tank C. XB will transfer. We need another. XB will transfer the material here to tank C. When tank B is getting empty, XB will close. New mixture is mixed for 60 seconds by MC. A mixer in tank C. After this step, temperature in tank A is increased up to 80. So this when this step is finished, we return to tank A. The current temperature should be around 50. We will increase the temperature up to 80, and when we reach to 80, and level should be 50. Again, we export the liquid to tank C. In the next step, level in tank C will reach to 100, and drain should be started till the tank is getting empty. New start needs operator intervention. Level in tank A should be maintained around 50. Make sure that opening of level control export valve have decreasing effect on simulated level. This is the simulation tip. When you open something, the level should drop. Temperature in tank C. Temperature in tank C should be adapted, or a mixture average temperature. By temperature in tank C because we enter several different liquids from different parts. We need to change the temperature based on situation. So let me start our function test. We should start from here, and we receive the message. We received the message related to current section, and it's also possible to trace the program in SFC. So we task is hold here. The level should reach to 55. So we need to wait. The level of tank A is provided in a random way from another part of plant. We don't have any control on that, and it's somehow very controlled in drop by drop. This tank is filled in a very sluggish manner. You can see that there is no other input. This tank the tank has only one input and two outputs. So the input is coming from another process, but it's drop by drop, very slowly. You can see that the level is increasing, and we should wait until reaching to 55. In the next part of the tutorial, I will tell you how the level is simulated. You can speed up the level accumulation, but this is the initial draft. So we reach to 55, and in here PID controllers are getting in automatic and external set point. So the temperature should be maintained on 50. The current temperature is 30. So the valve should open, and the mixture that is coming from here is getting warmed up, and the temperature of tank A will increase up to 50 centigrade. And this is so we have the inlet from here, and now we have the outlet here. Possibly this is a very small valve in order to maintain the level, and we use this PID controller in order to maintain the level on 50%. In order to go to the next step, we will monitor the steady state error signal. The error signal here, when it's in a certain window, we will move to the next part. It means that the level and temperature of this tank is maintained. It may take several time to reach to the set values, and when we reach to set values, XA will be true, and it will be energized. We will have the material transferred to tank C. So now we need to wait. We have overshoot here. We need to reach to 50 centigrade here, 50% here.